Hello everyone, welcome once again to another Power BI related tutorial by Team Slidescope. This is USA Pizza Orders Analysis project. In the first part, we studied about creating orders analysis dashboard. In this part, we are focusing more on delay analysis, trying to figure out the different fields that are given here. So what fields are causing delay in pizza delivery? So we are considering fields one by one, and in this example you will learn that. So we will create a simple measure, average delay time, and then we will try to figure out whether there are city wise there is a delay, there is a difference in average delay time. If it is a peak hour, is there more delay in peak hours or non-peak hours? Is average delay affected by traffic level, by order month, by pizza type that is being ordered, by different restaurant, and particularly by time of order hour? Like for example, here you can see that if time of order hour is around 8 p.m., average delay time is more as compared to 2 p.m. So this is something that we are going to learn in this example. Let's get started with this part. So this is USA Pizza Order Analysis dataset. On this dataset, we created an exploratory analysis dashboard. This dashboard, the main focus of this dashboard was to understand how many orders are we getting from different locations, restaurant wise orders, count and average by duration and category, and so on. Okay. Now this is part 2 that we are creating. First of all, I will copy the same dashboard. I will not synchronize the visual. That was summary dashboard, or we can simply call it orders dashboard, because in that part we studied about orders. But in this part, we have to study about, I'll just keep one visual, then we will keep others so that you will understand. In this part, which is part 2, we will study about delay. Okay, delay in orders. Okay, so this is pizza orders delay analysis. Like we are trying to understand what are the features, or what are the different factors which are resulting in delay of pizza delivery. Basically, in the data set we have information that, suppose this is a restaurant, consider any case. For example, this is Pap some restaurant. This is a order time. So someone ordered the pizza on this time, 7:15 p.m., and then delivery time was 7:45 p.m. Okay, it was a large pizza, it was a non-veg pizza. And here you have different type of examples, like whether the traffic was high, medium, or low. Okay, and was it a peak hour? Because sometimes peak hour means when more pizzas are ordered, like evening time can be a peak time, or dinner time can be a peak time in US. Then order month, payment category is there, and on the basis of that we have restaurant average time and estimated duration. This is estimated duration, like what was the estimate delivery time and how much delay was there. Okay, so estimated duration and delay is given here, and we have average, restaurant's average time is there. Since this is restaurant wise, not for that order. Okay, so and they have given the order hour as a separate hour, like 19. So you can see from 12, 13, 14 to 21, these are the hours in which these pizzas were ordered. And we also have pizza complexity, like how complex is it to prepare the pizza? Is it easy to prepare? Is it hard to prepare? So we have to check if pizza complexity is low, so is the delay also low? And if pizza complexity is high, is the delay also high? Okay, So here you can see delay starts from 9 minutes and goes up to 30 minutes. This is the delay and this is the estimated duration. So now on the basis of this information, first of all, we will change our KPIs. Okay. Forget that we have any KPIs. So I will just delete everything and I will start from scratch for this session. If we have to do delay analysis, so the first thing that we will consider is obviously how many orders were there. So information is given in order ID. We will simply add order ID here and we will simply count the distinct number of orders. Okay, so we will just click here and we will drag order ID here, and instead of first we will count distinct. Obviously this was discussed, but this is how you can count this because some students have joined for the first time. So this is number of orders that were ordered. Next, we have delays. Okay, in the example we have delay in minutes. So we want to check what is average delay in minute. Okay, so how can we do that? To find average delay in minute, we will simply write delay here in the field, and this will give us sum of delay, but we don't want sum of delay, we want average delay. And on an average a pizza is delayed by 17 minutes. Okay, then we have the estimated duration also, like what is the estimation of delivery and what is the delay. Okay, so estimated, so we will also see what is the average estimation time. So average estimation time, if you see, so you can see on an average they think that pizza will be delivered in 11.87 minutes, but it is given with a delay of 17.62 minutes. Okay, and you can rename them also. So you can select any measure and here you can select average of, and we can rename it as average estimated duration. So instead of average of, we will select average estimated time in minutes or something like that. So whatever you want to display you can select. So this is average of delay and average of estimate. Now my next question to those who have joined the class currently. So next question is how many orders are delayed and how many orders are not delayed. So for example, we have a filter. If we select is delayed false, you can see here we have delay 19, estimated 10. If we select delay as true, is delayed as true, so you can see estimated 17, delay minutes 17. Okay, so they have given the information whether this pizza was delayed, yes or not. So if I ask you, I have to find count of orders that were delayed. So I'm just writing my question here. You can also write it down. Count of orders that were delayed. How to find that? So here we are just going to find question number 5. I have given some questions that you can use for practice. For my first question, how many orders are delayed? We simply have to apply a filter. Okay, and that filter is going to be simple, that calculate count rows. Okay, you can do count rows, you can do distinct count of order ID, you can do anything like that. So that will be your measure, right? But for your measure you have to apply a filter also, and your filter will be pizza order is delayed equal to. true. Now I will first of all create this measure. So if you see, I have created a separate measure table here. In that separate measure table, I'm going to create a measure, and that is going to be delayed orders, which is going to return a value count. First of all, let's see if a correct answer is coming. So you can see 210 is coming as answer, which we can go and confirm. So for here we will just go and is delayed. Yeah. So here if we select is delayed true, so you can see 210 filtered rows. That means that our answer is correct. Now why I have given this question in particular is, my question is, what is the data type of this column?
Binary data.
So this is a boolean value, which is data type is true and false. Because the data type is true and false, that's why when you will compare these values,
Oh,
so that's why when you will compare it, you will not write it like this. Like if we write it like this, for example, true. Okay.
true
So
will come.
it will come as blank, because this will be correct if columns data type is a text value. Okay. If the columns data type is not a text value but a boolean value, so you will write true and false as a function. Okay. So this is the case. So when you will do this, then it will come. Similarly, if I ask you how many orders were on time, so very simple, what you will do is just write false here, right? So is delayed equal to false? So that will be orders on time. So we can say that most of the orders were on time, but yeah. So now here we have a simple column chart, and before that, so we also have another KPI which we can fill. Let's see the data. Here you can see we have traffic impact. Okay. So traffic impact is like on the delivery, what is the impact of traffic? One means low impact, three means high impact, right? Here we also have information of pizza complexity. We have estimated duration, and so we will also see what is average pizza complexity, because when we will apply some filters, we will be able to know that. So for that, we will apply pizza complexity here, and pizza complexity, when you will add here, you have to select average. So average pizza complexity is 9.47, and you'll rename for this visual as AVG. The whole purpose of analysis is to analyze that if pizza complexity is the main reason for delay, or is traffic the main reason for delay, and so on. So here the
Yeah.
filters that we, yeah, yes, there can be many reasons, Sharath, and that's why we are seeing which which feature has more effect on delay, right? So that is what we are selecting here. Now let's say we want, we have the first column as city. Okay. First categorical field as city. So we want to analyze in which city, or is city a region, like is there some kind of a relation between city and delay. So for that we will select average delay. So it will be better if we create average delay time, right? So we will create a measure called average delay time, and the formula will be simple:
Average.
average of delay. So pizza orders delay in minute. Okay,
Column name.
column name. So this will be our average delay time, and when you will actually select the visual, this is a simple stack bar chart. In that stack bar chart, On y-axis we will select a categorical field, and on x-axis we will select this. So you can see, yes, in some cities average delay time is less, in some cities it is more. We have to check, is there any kind of filter applied here. So because I applied the filter, so I will clear every filter. So now you can see we have the data that in some cities average delay time is only 13, but in some cities like Fort Wayne, or we have city or county like Newark, so their average delay time is more. So will you consider that city is a important field to calculate delay, right? Because in different values we are seeing different trend. So this is average delay time by city. Now we will simply copy this and put it here. Next is delivery duration, delivery efficiency. These type of things are there, good. But when we are going to consider this, obviously is delayed is something we know that if is delayed is yes, or if is delayed is no. So average delay time is going to reduce or increase. First of all, we'll, instead of payment method, we will add is delayed, and we'll use false. So if is delayed is false, you can see this value comes to 23. If delays is true, you can see this value comes to 26 average. So that's why we can check that, yes, uh, this is a important thing. Is peak hour is another thing. Like we want to see, is average delay time more or less in a peak hour. Okay, so for that we will select, and is peak hour will be either yes or no, true or false. And I have given you a simple indication that for this type of data, if we create a donut chart or if we create a pie chart, it will be better. So we are creating a donut chart, and if it is peak hour, you can see that average delay time is 17.86, which is actually close to average delay minute. But when it is not a peak hour, average delay time is 13. So that means in peak hours, obviously, we have more delay in pizza delivery. So here you have slices, you can select colors. So like I have some colors over here. So I will copy the color code. So this is the color code that I will use in slices also. So here I will select this, and if it is false, I am going to select a yellow color. Now this is data label, okay, or detail label. Detail label color is yellow here. So in values, instead of yellow color, we can select any other color, dark color, maybe this color, and select bold. So so that we can see the information. We can reduce its size. Next is we can also go to legend and say legend position is bottom center, so that at least our numbers are visible properly. Okay, so these type of settings you must have done. uh, we have done various other data sets. So play with detail labels. You can reposition them. You can use different positions, but this is something that is giving us another indication. Next is weekend. This is also a true and false kind of information. So we will select this, and here also we will try to answer the question. So is weekend, if it is weekend, whether it is same. So let me format the printer, or maybe we have to select the slices again. So here, if it is weekend, you can see for true I am selecting this color, and for false I am selecting this color. So what do you get from this information? Like in weekend there there is more delay, or on weekdays there is more delay, or this particular variable has a very weak impact on delay. What will be your conclusion, Mohan and Chadar?
Weekend is not impact on delay. Something.
Very
Yeah.
weak correlation or weak impact, right?
Yeah.
Because
Yeah. Right.
we can see the numbers are very close to each other, 50.25 and 49.75. But in this case, what will be your conclusion?
Both are very close. Something.
Well, but here it is close to 57%, right?
Mm.
So
But there is a, we can say, no impact on weekend.
yeah, in weekend we can say. So what happens is when you will prepare some kind of formula to calculate estimated delay, right? I'm just giving a hypothetical situation here, a simple example situation. Let's say delay is our output. So you know our inputs. So it will be like x into city code plus y plus x, so it will be like x1 into city code or m1 into city code plus m2 multiplied by peak r, whatever value is there, 0 or 1, plus m3 into something as weekend. So formula will be like this, okay? You will consider all other variables. So to count the delay, obviously this is done by machine learning algorithms, but
What is
before
the
that,
M1?
so the idea is value of m1 will be low or high, right? Depends upon how much effect that particular variable has on our target field, right? So that is the idea. So that's why if some variable has almost no impact, so you can drop this data set in your model. Like you will not use this, you will drop this column, you will not use this field in your calculation. So this is average delay time by weekend. Next, we also have month information. So because these two are almost similar values, I'm just using the space here, okay? And you can create more charts using other spaces, but just a minute. Yeah, now it should be. I will just copy this chart one more time and try to put it here, and I will actually reduce its width. You can adjust where you want to place them, and I will reduce its width as well. Try to give some gap between them. Okay. Now next is month wise. So because some month can be a rainy season, a winter season, some month can be a summer season. So is month some kind of factor for delay? So for that we are going to select month. So is delayed if we can order month. So if you will see order month, then you are seeing that in case of June, average delay is 18.81, which is actually more than the overall average. And in July, it is 16. Okay, so that's how you can see that July is the best month. But yes, we can see some difference is there. So this is average delay time by order month, and we can also use some chart like this or some chart like this. Okay, so this is June and on, but I think this is giving us a better idea, so I will stick with it. This is average delay time by order month. Next, what is so this is order time, which is very important thing for us, and actually to help us in the data set from order time, the order R is already there in the data set. So this is like 12 p.m., 13 p.m., 14 and 21, right? So we have to check order R wise average time. So I will select line chart here as to understand this. And so because this order R that we have right now, this order R was originally given as a number, okay? But actually for us it is just like a label, like 7 p.m., 2 p.m., 3 p.m., just like a label. So what I have done is I have changed this order or as a text. I'm just taking it as a categorical value, okay, not a numerical value. And now if I take a line chart, and in that line chart I put order or on the x-axis, and on y-axis I put average delay time, okay. So you will see that average delay time by different hours is different. Like if it is, if the R is 20, average delay time is 19. If it is 21, okay. So actually average delay time is highest in 19th hour, okay. This is something that you can do. And you can also take delay duration from here as well. So for example, if you have to see in which hour did we have maximum delay, right? So then you can take delivery duration and you can select sum of it. So if you will see sum of it, you can see because most of the pizzas may have been ordered in 19th hour. So that's why we are seeing sum of delay mostly there. But if you will select average, you will get the same answer, right? That in 90, so here if you will select, you will see that in 19th hour, what is average delay, in 20 hour, what is average delay, in 21 hour, what is average delay, and so on. So this is average of delivery duration by order R. Okay, this is average delivery duration, and how much it is taking. And if you actually want to see delay in minutes, so that is going to be the same answer, average delay. Okay, why, whether you select from here or whether you select from here, we will keep it like that. And for this also we will copy the same styling because we are using some colors here. Now the thing that we are going to do is, here in our line we are going to select a line, and for this we are going to select this color for line. And for data labels, which is yellow, either we should select a dark color or some other color. So we will select a dark color, okay. Now looking at this line, do you think that order R is a factor that is affecting delay or that is causing delay? Like it has some effect on orders being delayed, Shadat,
Yes, good sir.
right? Because we can see in
Yes,
different hours the numbers are different, right? So that's how you
yes.
will conclude. And we can select that, and we can select the area chart also, just to see it in a different way. We can select like this also, we can select like this also. There are various ways of showing the same data, but we'll keep it like this and maybe select a chart like this. So this is average delay time by order R, and this will be an important variable for our calculations, okay. Now here we have is we can order our order month that we have done. Similarly you can see pizza size or pizza type wise also, okay. Like if it is a particular type of pizza, do we have more delay? So for that let's select a simple chart here, and we will select a tree map chart. And in the tree map chart, as a category we are going to select pizza type, and in values we are going to select the average delay time. So now it is going to link it as stuffed crust, Thai chicken. You can see on the basis of different type of pizzas that we have, what is the average delay time. Let me copy this formatting and apply here. We can do one more thing here, that here you can see the colors are given. For every different type of pizza, we have a different type of color. But we can do simple thing, we can select it. Instead of rule, we will select gradient. This is something we have done previously also. And here in our measure, we have average delay time. So when average delay time is low, we'll select a yellow color. When average delay time is more, we will actually select uh, this color, which is our theme color. And now on the basis of that, you will see. So this will do, like, it will not make our chart very colorful, but it will actually use the same colors, three colors that we are using. One we are using yellow, one we are using orange, and third is the purple color. So this FX or this conditional formatting will help us there. So, and this will also give us information that in which particular type of pizza we have more delay. Okay. Now we can also copy this and put it here. So that's why having having this type of charts is useful, because in a very less amount of space we can display more values. Similarly, we want to see that obviously there is pizza type. We also want to see restaurant wise is the same condition, like we have 10 restaurants, 10 5 restaurants. So you can see, if you see restaurant, the restaurant name Mar is their average delay time is 18.44, and for restaurant lit it is 16.62. These are some random restaurant names. uh, so you can see, yes, restaurant wise also there is a difference. Like some restaurants are delivering on time, some restaurants are having more delay time. So this is average delay time by restaurant. And now similarly we have topping density, topping count, traffic impact. So you can see the traffic impact is also given as 1, 2, or 3. Okay. So let's see, if we use a bar chart here and we select the traffic impact and then we select average delay time. So you can see on the basis of traffic impact also, you can see that if the traffic impact is more, that means there is more traffic, then delay is more. And when there is less traffic, the impact of traffic is less, so the average is actually less than the overall average, right? And you can see for traffic impact 2, the average is slightly above the overall average. So this is average delay time by traffic impact that you can get from here. And in the similar way, you can find out other impacts also. Like this is, you can take it as a homework, that you will try to create a delay analysis dashboard with more charts. So so similarly, you can also see we have a traffic level. Okay. So like instead of traffic impact, if you want to keep traffic level, high traffic, medium traffic, low traffic, it is just the reverse of that, right? So traffic impact is just the label that we are using there. So on the basis of that, you can see. And here, if we simply use line and stack chart, and in that line and stack chart on live axis, we select average traffic impact. So you can do it like that, but I don't want to complicate this. We'll keep it simple, and a simple chart like this is sufficient to tell that yes, there is an impact of traffic on pizza delivery. Obviously that is a common thing also. So this is basically the idea. When you do exploratory analysis, you try to find out, first you consider something as your target field. So for example, we considered average of delay minutes is our target field. We are trying to see if average delay minutes is high or low for different categorical values. If it is high, we will understand that number of values in this particular field are different. So yes, we will use this for analysis. But for cases like this, whether it is weekend or whether it is a weekday, like there is hardly any change in the delay. So if you want, you can drop this data set for your machine learning analysis. So this is something that you can try. And then in next example I will teach you ranking pizza by delay. And I have prepared this, so where we will learn rank and rank x use. Okay, it is going to be a short third chapter for this rank and rank x. So here you can see rank by speed, rank x has been used, and rank by delay, rank function is used. Okay, here you can see. So I will explain you the meaning. This is an important topic because earlier we were discussing rank and rank x, so I have given example here. Now before that, first get your get familiar with this data set and try to create these simple EDA dashboards like order dashboard and delay analysis, and then we will move further with other type of questions on this data set. Till then, have a nice day.